At any given second, billions of devices, phones, laptops, servers, are attempting to talk to each other all at once. It looks like total chaos, yet somehow your emails and messages rarely get lost in the noise. That reliable delivery happens because of a very specific tool, the IP address. You can think of an IP address simply as a unique digital mailing address assigned to your specific device. In the world of networking, there is an absolute unbreakable rule. If a piece of hardware wants to send or receive information on a network, it must have an IP address assigned to it. You cannot participate without one. Without this precise standardized addressing system, delivering data across the globe would be physically impossible. The entire internet would freeze up instantly. Here is a standard IPv4 address, 192.168.1.1. Computers process this as 32 electrical pulses. For human readability, dots separate the data into 4 distinct chunks, called octets. Reading these left to right works like a postal address. You start broad with a country, narrow down to a state, then a city, and finally the exact house number. These 4 numbers form a geographic funnel designed to narrow down the entire expanse of the internet until it finds one specific device. These addresses come in 2 main flavors, public and private. A public IP address is the official street number on the outside of this physical house. It is globally unique, so the entire outside world can find the building. Inside that house, you have labels like Bedroom 1 or the kitchen. Those are your private IP addresses. They only make sense to the people currently inside the house. If you yell, "Take this to the kitchen" to a mail carrier outside on the street, they won't know where to go. This setup keeps your internal devices invisible to the outside world, and it prevents the planet from running out of official public IP addresses. By using private IPs, local networks can operate as secure, self-contained bubbles that are shielded from the public internet. If a university or a corporation puts thousands of computers on one giant, wide-open network, every device constantly shouts over the others. It creates massive digital traffic jams and security risks. To solve this, engineers use subnetting. This is simply the process of slicing one massive, unmanageable network into smaller, neatly organized segments. To perform this slice, networks use a tool called a subnet mask. It acts like a template that slides right over the IP address to draw a firm boundary line. That mask splits the IP address into 2 identities. Everything to the left of the line becomes the network portion, the neighborhood identity. Everything to the right becomes the host portion, the specific house inside that neighborhood. You will often see a shortcut at the end of an address, like a slash followed by the number 24. This is called CIDR notation. It tells the computer exactly where to drop that dividing line between the neighborhood and the house. Ultimately, subnetting creates a system of digital zip codes. It ensures that data stays within its local neighborhood unless it actually needs to travel out to the broader internet. Let's apply this to a real-world network block, 192.168.1.0/24. The /24 at the end tells the computer to lock the first 3 numbers firmly into place. The sequence 192.168.1 becomes the permanent name of this specific neighborhood. Because each of these numbered blocks can hold any value from 0 up to 255, that final position provides a total of 256 possible mathematical combinations for devices to use. Only 254 of those spots are usable for your devices. This is because the very first address acts as the entrance sign for the neighborhood, and the very last one is like a megaphone used to broadcast messages to everyone at once. This strict mathematical system allows network engineers to precisely tailor the size of a network without wasting a single address. By creating these tight, organized digital neighborhoods, we get faster troubleshooting, better security, and highly efficient address allocation. While networking can feel complex, it is simply a series of logical systems built to keep us connected. IP addressing and subnetting act as the invisible, reliable scaffolding holding up our modern digital world. Thank you for watching. If this helped you understand the internet's neighborhoods, please leave a like, hit the subscribe button, and activate the notification bell so you never miss an update.